Okay, so guys, there's millions of people watch the presidential inauguration of Trump. Everybody's watching that. I'm gonna try to get in the video for you guys. All right. So let's click away from this page here, and let's go to one of my sites. One second. So I'm gonna go to. We're gonna go to IBM's website. Let's go to IBM's website. IBM Quantum. IBM Quantum. Platform. And you guys can do this too. You can go to IBM's platform and play around and use their quantum composer. Okay. All right, so I'm on their platform. All right, I'm gonna do a few things. Like I said, while everybody's watching the Donald Trump inauguration, I'm gonna try to knock out a little short video for you guys. All right, so I think the last video I showed you all of the gates and their basic functions and how they work. In this video, I'm just gonna just have some fun, and I'm gonna show you some gates, but I'm gonna show you some circuits, and just kind of just play around with it and just have fun. Okay, so you already know that I'm gonna put the Hadamard gate on the Q3 line. You already know that the Hadamard gate puts the qubit in superposition, right? Let's put that back. But you could also have a Hadamard gate here. So then you have the Q0 in superposition, which is a circuit. And you have the Q3, you have that in superposition. So you have two qubits in superposition separately. And you see that here. Let me go down. So you have this qubit in superposition, 0, 1 at the same time, and then you have this qubit here at 0 and 1 at the same time. Two separate qubits in superposition, right? And then I could have another one here, right? And when you have three qubits, in superposition, now you have where you have a total of 8 states that those three qubits can be in. They can be in a total of 8 different states. So you see a state here, here, all the way to 8. When you have 4 qubits in superposition separately, they could be in a total of 16 different states, and you see it here. See how it changed? All right, now another thing I'm going to show you is take some of these Hadamards back. Let's take some of these Hadamards back. All right, let me show you these states real quick. Hold on, let me close my door. 1 second. Okay, I'm back, guys. Okay, so you see this Hadamard gate. Remember I said that it could be in 2 different. When you have a Hadamard gate, a qubit is in the Hadamard gate, it could be in 2 states, right? Okay, so let me show you something real quick. Let me blow this up. Real quick. Okay, so you see this block sphere here, right? You see this block sphere. So you see that when I did the Hadamard gate, the block sphere shows that the qubit is in 2 states, right? Now, watch when I add another Hadamard gate to a second qubit. Now you see those 2 qubits are in 4 states. 1, 2, 3, 4. When I add another Hadamard gate, 3 qubits, you're going to see that it's in 8 different states on the qubit. 1, 2, 3, 4, 5, 6, 7, 8. Right? This qubit is in 8 different states at the same time. Why? Because 3 qubits are in Hadamard, have a Hadamard gate. puts them in superposition. Add another one, and now this qubit is in 16 different states simultaneously, with me adding a Hadamard gate to 4 different qubits. Right? 4 different qubits are in superposition, so that gives me a total of 16 different states that this quantum computer can do calculations in at the same time, which shortens the amount of time that a problem can be solved, right? So you have that. All right, so I done went through the Hadamard. Hold on a second. Let me put those. Dang, this thing keeps disappearing. One second. Erase some of these Hadamards. Let's erase some of these. Okay, trying to see if there's anything else I can show you. I guess I can go through and show you the X gate. See, the X gate has one state, right? It's in the one state, right? When you add the X gate, it goes from the 0 to the 1 state, right? Because initially it starts off at the 0 state. So when you add X gate, it goes to the 1 state, and you see that here, the 1, right? So it says 1. See if you can see that. Let me blow that up. Okay. And then when you add the X, another X, it goes back to the 0 state. You see it here on this block sphere. All right, so I showed you that. Just giving you different explanations of the same things. So you can see it from different angles, and you can the more ways I explain it in different ways, the more people will understand it, because everybody understands and learns things differently and in different ways and in different angles. Okay. Let me think of something else. Let's see something else. Let's try a let's try 2 qubits that are entangled. Okay. So you got 2 qubits that are entangled. So you see that the first qubit is a 0 and 1, and then you see the second qubit is a 0 and 1. You got 1 1 0 0. That means that these 2 qubits are entangled, right? When you see a 0 0 here, 1 1 here, that means there's 2 qubits that are entangled. Now, that's when you have it the circuit form like that.